we're going to talk about graphing linear equations. And so first of all, we need to define, what in fact a linear equation is. So think about it. What is a linear equation? Ideas? Yes, sir? A line. And if you look at linear, the root word is line. So let's think about that. Line equation. Line equation. So a linear equation is an equation of a line. And so what I have here is I have what's known as the standard form of the equation of a line. So as with anything, we have a formal equation here. And our formal equation is ax plus by equals c. I need you to file that down to memory. Probably would be a good idea to write it down. Okay? This is something that we will study through Algebra 1 all the way into Algebra 2. And basically, the standard form of the equation of a line is ax plus by equals c. A, b, and c are all integers with a GCF of 1. A is greater than or equal to 0, and a and b are not both 0. So after you get that written down, I want you to think about what does a greater than or equal to 0 mean. So when it says that a is greater than or equal to 0, what does that mean?
It's not negative.
It's not negative. Perfect. Okay, so a here has to be positive. So this is a fancy academic way of saying that a is positive. So remember again, a is the number in front of the x, b is the number in front of the y, and c is the number all by itself. So that is our standard form of the equation of a line. I'll let you go ahead and get that down, and then we're going to look at some examples. I'm going to be using the expressions. Now, if you didn't quite get that all written down, at the very end, I'll go back and you can end up writing it down. So I will give you that time as well. So let's go ahead, skip that one. Let's go ahead and look at this. It says, is the following a linear equation? Yes or no? So I want you to go ahead and answer that for me. Is that a linear equation? Is that a linear equation? Yes or no? Okay, so I need you to go ahead and answer, please. Let's see what we got. Whoa. Okay, so real quick. That is in fact a linear equation. If you notice I have an x, a y, a number, looks real similar to the one on the first page. And so what we're going to do now is we're going to go ahead and write that in standard form. Okay, we're going to write that in standard form. So standard form, ax plus by equals c. That is what standard form is. So when all is said and done, this is what I want my answer to look like. So how am I going to write that equation in standard form? What is the first thing I'm going to do? Add 3x to both sides. Good. Because remember, I want the x's and the y's to be together. So on the left side, what do you get? 3x plus y equals 4. Is that equation in standard form? So first of all, is A positive? Yes. Okay, second, are A, B, and C. So A is 3. What is B, by the way? 1. Very good. And C is 4. Now, when it said a GCF of 1, what that means is that there can be nothing in common with the 3, the 1, and the 4. Is there nothing in common with the 3, the 1, and the 4? No. So basically it's saying you can't reduce it down. And so this is actually your equation in standard form. That is what the equation of a line looks like. Let's go ahead and look at this one. Is that a linear equation? So is that an equation of a line? So based on what we've looked at, is that an equation of a line? No, good. Those of you that answered no, why did you answer no? That's an x and a y. If you remember, the equation of the line didn't have x times y. It had an x, it had a y, and it had a constant. Okay, so nothing like x times y. So that is not an equation of a line. Is that a linear equation? Is that a linear equation? For those of you that answered no, why'd you answer no? Because I think... Okay, right, because if you remember, though, at the very start, it said A was greater than or equal to what? 0. So according to this, A could be 0. And so really, if you think about it, since I don't have an x there, it's actually there, it's just a 0x. And if I had something like this, would you agree that's kind of the same thing? Yeah, so this is actually the equation of the line. All right, so now what we want to do is write that equation in standard form. Now notice I don't have an x. It's a 0x. I'm not going to put that in there. What is the one thing, though, that this doesn't fit from that equation of a line in standard form? There's one problem here. Close. The fraction. Because what did it say A, B, and C all had to be? Integers. Is 1/3 an integer? No, so I got to get rid of that fraction. So I'm going to multiply by what?
3/1.
3/1. So I'm going to multiply both sides by 3. Whatever you do on the left, you got to do on the right. So when I multiply that by 3, what does that become on the left? Y, yep, equals?
3.
Yep, -3. Now that is in standard form. Now I don't need to put the 0x in there. I know there might be some people that require you to write this as 0x plus y equals -3. I'm not going to make you do that. Okay, I don't want you to get in that habit. So y equals -3 would be in standard form. The x-intercept is where the graph crosses the x-axis. So the x-intercept is where the graph crosses the x-axis. Okay, and so the equation, or the point at which the x-intercept is it's some number, comma, 0. Because this is your x value right here. And this is your y value right here. Now the y-intercept is where the graph crosses the y-axis. So what is your x value there? 0. So here's your x value. Here is your y value. And so if you notice there's a picture down below. It says here at the y-intercept 2, the x-coordinate is 0. So this is our point for the y-intercept. At the x-intercept -4, the y-coordinate is 0. So here is your point for the x-intercept. So now what we're going to do is we're going to graph lines by finding the intercepts. And so if you look here, it says find the x-intercepts and the y-intercepts of the line graphed at the right. Okay, so you have four choices. What is the x-intercept and what is the y-intercept? So let's review. X-intercept is where it crosses the x-axis. Y-intercept is where it crosses the y-axis. Okay, so with that in mind, I want you to look at that graph. Tell me which of the answers is correct. A, B, C, or D. A, B, C, or D. And the answer is B. Okay, good. Because you should find that the x-intercept is 20 right here, and the y-intercept is 30. All right, so here we go. Another question. Find the x and the y-intercepts of the line graphed at the right. So remember again, the x-intercept is where it crosses the x-axis. The y-intercept is where it crosses the y-axis. Ah, good. D. Okay, now let's look at the difference between D and A. In A, it says the x-intercept is 0. For that to be the case, the x-intercept would have had to cross the graph right there, and it doesn't. Okay, this graph never touches the x-axis, so therefore it doesn't have an x-intercept. All right, so now it says a swimming pool is being drained at a rate of 720 gallons per hour. The table shows the function relating the volume of water in a pool and the time and hours that the pool has been draining. Find the x and the y-intercepts of the graph of the function. So we've got two answers we need to find. We need to find the x-intercept. I'm going to abbreviate that. And we need to find the y-intercept. Any guesses on the x-intercept? Okay, let's think about that. Let's look here. Notice here, x is 0, y is some value, right? Down here, x is 14, y is 0. So those are the things you're going to look for. You're going to look for where x is 0 or where y is 0. Now, if you remember back to that little slide where we had x and y intercepts, the x-intercept was where y equals 0. So what would this x-intercept be? 14. Remember what I said, it's where y equals 0. So the x-intercept we would write as a point, it would be 14, 0. Where is the y-intercept going to be? 0, 10,080. Now be careful when you write this not to put commas, because if you see two commas you're going to think that that's actually an ordered triple. And so anyway, just don't put commas there for the 10,080. Alrighty, so describe what the intercepts mean in this situation. So let's look at that graph. It's going to make you think a little bit. Okay, I have two intercepts. I have this intercept here, which is the what intercept? The y. What is this intercept here? X. The x. So what does that y-intercept mean? So this 10,000 means that there is 10,000 gallons in the pool. To start with. And what intercept is that? The y. Okay, so the y-intercept in this case tells us that there are 10,000 gallons in the pool to start with. What does the x-intercept tell us?
How long? 14 hours.
It took what?
14 hours.
It took 14 hours. Oh, 14 hours to do what?
Drain the pool.
To drain the pool. So that's how you would answer a question like that. You just kind of have to look and interpret. Okay, so now what we're going to do is we're going to graph the following by using the x and the y intercepts. And so we have to do a graph. So remember, the x-intercept, okay, was where what equals 0? Y equals 0. So this is what you're going to do. You're basically going to do two problems. You're going to do your x-intercept, and then what we're going to do is we're going to come down here and do a y-intercept. And this is fairly easy. Okay, the x-intercept, we are going to let y equal 0. So wherever I see y in the problem, I'm going to let it equal 0. So I end up getting negative x plus 2 times 0 equals 3. Well, what's 2 times 0? 0, right? So I end up getting negative x equals 3. Well, I need to solve that for x. So what do you need to do? Yeah, so basically I'm going to divide by a negative 1. So what does x equal? Negative 3. So I'm going to come to this graph right here, and I'm going to plot x equals negative 3. So there you go. Now what do you think I'm going to let go on the y-intercept? What am I going to let? I'm going to let x equal 0. So my problem will be negative 0 plus 2y equals 3. Well, negative 0, what do you know that is? It's just 0. It's gone, right? So I end up getting 2y equals 3. What do you need to do to both sides there? Divide by 2. Very good. So what does y equal? 1.5, 1.5. So that means I'm going to go to the y-axis up here, and I'm going to plot 1.5. What are you going to do with those two dots? Connect them. That's right. You're going to connect them with a line with arrows. And there you go. And there's what your graph is going to look like. That's all you have to do. Okay, let's see what we got to get. Oops. Sorry. So let's look at this one right here. This one says to graph y equals 1/3 x plus 2. Okay, so this one you could use intercepts, or what we could do is we could use a table. Now notice I already have a table there. Why do you think I went 0, 3, and 6 instead of 0, 1, and 2? Where do you think that? Yeah, I see I've got a fraction here. So what I'm going to do here is I'm going to go with multiples of 3. If it would have been like 1/4 x, what would you have done? Multiples of 4. Yep, so you would have done like 0, 4, and 8. If it would have been 1/2 x, you could have done 0, 2, and 4. The whole purpose of doing the multiples of 3, 2, and 4 is that your answers are going to be a lot easier. So if I plug in 0 here for x, I end up getting 1/3 times 0. What's 1/3 times 0? 0. Add 2, and you get 2. So I'm going to come over here and place a dot at 0, 2. Now what I'm going to do is I'm going to do the same thing with 3. So I'm going to take 1/3 times 3. What is 1/3 times 3? 1. Add 2, 3. See, the whole purpose of using the 3 and the 6 is that you're going to get whole numbers now as your answer. So I'm going to put a dot at 3, 3. Your next one, I'm going to take 1/3 times 6, and then I'm going to add 2. What is 1/3 times 6? 2. Add 2, you get 4. So 3, 4, 5, 6, and there you go. So now all we need to do is connect the dots again, and there you go. Questions? Alrighty, you know what? I think we've probably had about enough right now, so I'm going to go ahead and let you go on your assignment. If you have questions, that's what we're going to start tomorrow. Okay? on page 159 through 160, 14 through 42, the evens. Now, if you like to use graph paper, I've got graph paper in the top drawer that pulls out. You can come in and get it anytime if you need graph paper. If you don't want to use graph paper, I understand as well. So,